Hello. Let us see a question which states that an ammeter and a voltmeter are connected in series to a battery with an EMF 6 volt. When a certain resistance is connected in parallel with the ammeter, the reading of the voltmeter decreases 2 times, whereas the reading of the ammeter increases the same number of times. Find the voltmeter reading after the connection of the resistance. Okay, so the initial circuit is like this and the final circuit is like this. Initially, the ammeter and voltmeter are connected in series. I have assumed that the current at that time is I. When the resistor is connected in parallel with the voltmeter, I have assumed that the current in the circuit has changed to I1. Okay, let us come to a point where I can say that the voltmeter has very high resistance. Okay, due to that, the equivalent resistance of this ammeter and voltmeter will be very high, so the current will be less. Due to that, the ammeter is reading less current in this scenario and more current in this scenario. It has been said in the question that the ammeter reads 2 times more in this case. Okay, I have assumed that the resistance of this ammeter is R, small r. Okay, initially let me say that the potential difference between these two points will be shown as the potential difference in the voltmeter. So let me calculate the potential difference between these 2 points A and B using Kirchhoff's loop rule. Okay, and BA minus BB will be equal to BA minus this point, means the potential difference between these 2 points, and plus the potential difference between these 2 points. The potential difference between these 2 points will be minus I into R, where R will be the resistance of this ammeter. I have written the equation below, and this is like that. I minus I R1. Minus is because I am moving in the opposite direction of the current, and plus 6 is because I am moving from high potential to low potential, is equal to V1. I have assumed that V1 is the reading of the voltmeter. Now the resistance is connected in parallel with the voltmeter. The second case. In that case, I have assumed that the current is I1. That's why I have written the equation as minus I1 R1 plus 6 is equal to V2, where V2 is the potential difference, where V2 is the reading of the voltmeter at that time. Okay, it has been given that 2I is equal to I1, so I have written that I is equal to I1 divided by 2. It has also been given that the potential difference decreases. V2 is the final potential difference and V1 is initial potential difference. So I can write V2 is equal to V1 by 2. I have assumed this equation as equation number 4. From 1, 2 and 4, I have just formed a second equation. This is like this. This is like this. V2, V1 and divided by 2. And just cross multiplying, and after that I get, and one more thing, I have replaced this I by I1 by 2 from equation 3, and from there I get I1 R1 is equal to 4. Now I have been asked that what is the potential. The question asks that what is the potential difference, final potential difference, means what is the reading of the voltmeter, final reading of the voltmeter, and final reading of the voltmeter is minus I1 R1 plus 6, and I have just found out that I1 R1 is equal to 4. That's why I have written here minus 4 plus 6, it is 2 volts. So the answer will be 2 volt. Thank you.